Find g of f of x and the domain of g of f, where f of x equals x squared minus 3x and g of x equals the square root of x plus 2. First, let's find the composition function g of f at x. By definition, that's g evaluated at the values that f of x takes on. That is g, if we substitute f of x's expression here, we'll have g of x squared minus 3x. And now the placeholder x in the function g can be replaced with x squared minus 3x. So g of x squared minus 3x will equal the square root of x squared minus 3x plus 2. Simplifying that by removing the parentheses gives us the x squared minus 3x plus 2, and that's factorable into x and x. We can have a minus 2 and a minus 1, and if you multiply that back out, you'll find you'll have x squared minus 3x plus 2. So that's the expression for g of f. Let's look at the domain. Now recall that by definition the domain of a composite function is found by looking at places where x is restricted when it's fed into the first function, that is in this case f of x. So we may have some restrictions on the domain from here. And secondly, when the output values of f are fed into the function g of x, that's g of f of x, we apply the function g to the output of the function f. And in this process we may get some additional restrictions. These restrictions are restrictions on the domain of f. These restrictions come from making sure that f of x is in the domain of g, and so there will be restrictions on x so that we make sure that the f of x values are in the domain of g. Alright, let's have a look at each of those. The first restrictions come from the domain of f. F is the function x squared minus 3x, and the domain of f is the set of all real numbers. So there are no restrictions coming from that first step. The second step comes from restrictions where f of x may or may not be in the domain of g. So we need f of x to be in the set of all x from minus 2 to infinity, or the set of all x such that x is greater than negative 2. That's because the domain of g is precisely that set. X has to be greater than negative 2 in order to evaluate the square root of x plus 2. I should say greater than or equal to negative 2 there. So what does that mean? F of x is the function x squared minus 3x. What we need is for that to be greater than or equal to negative 2. If we simplify, we see that that means that x squared minus 3x plus 2 must be greater than or equal to 0, and that is the restriction that we would get if we started with our function g of f and asked ourselves what the restrictions on the domain would be. So you have a couple of options for evaluating this portion. We nonetheless need to find out when this is true in order to identify the restrictions on the composite function's domain. Well, this is the graph of a parabola. In fact, we've factored the quadratic expression here, that's x minus 1, x minus 2. So what we see is that the roots of this particular parabola are at 1 and 2. And because this is a parabola with a lead coefficient of 1, it opens upward. And so the parabola's shape must be something like this. We can see then that the y values on this parabola are negative between 1 and 2, which is to say that this expression is negative between 1 and 2. And so this expression cannot be under the radical between 1 and 2. However, everything over here gives a positive output, and everything over here to the right of 2 gives a positive output. And so the domain is the set. It's the union of the set from minus infinity to 1 with the set 2 to infinity. That's the domain of f of g of x, or rather of g of f of x.